Students, this question was asked in NEET 2024 from the chapter Dual Nature of Matter and Radiation. If c is the velocity of light in free space, the correct statement about photon among the following are: the energy of a photon E is equal to h nu, the velocity of a photon is c, the momentum of a photon P is equal to h nu by c. In a photon-electron collision, both total energy and total momentum is conserved. Photon possess positive charge. Choose the correct option given below. Students, we have studied that light propagates in the form of waves according to Christian Huygens wave theory of light. But according to Newton, it consists of corpuscles or particles. Okay, Newton much ago had given that light consists of particles. But later, according to the quantum theory and after further development in Einstein's famous photoelectric equation we know, and he propagated that light consists of particles that are characterized by their frequency nu. Okay, light consists of particles those particles are called, students, photons. Lights consist of particles known for photons, and each photon is characterized by its frequency nu. The energy carried by a photon or a particle of light is h nu, where h is Planck's constant, student. Okay, h is Planck's constant, nu is the frequency, is the energy carried by the photon or particle of light according to Einstein's particle theory or quantum theory of light or corpuscular theory of light, student. So E is equal to h nu. This has come from Einstein's theory. This is very famous relation. This is correct, we know. So option A is correct, student. And the velocity of a photon is c, as light travels in vacuum with speed c, that is equal to 3 into 10 to the power 8 meter per second, or 3 lakhs kilometer per second. We know the speed of light, student. So velocity of every photon is c, because photon is nothing but particle of light. So option B is also correct. The momentum of photon, students, we have studied the de Broglie hypothesis, student. De Broglie hypothesis. And what is de Broglie hypothesis tells us? That tells us that lambda is equal to the wavelength of a photon is equal to lambda is equal to h by p. According to de Broglie, a photon exists in the form of a particle as well as in the form of a wave, and as Einstein told that the photon can be associated with a frequency, de Broglie told that every photon is also associated with, or matter is associated with, a wavelength, characteristic wavelength, and the relation is lambda is equal to h by p. And this was also experimentally proved by Davison-Germer in their famous Davison-Germer experiment. You have studied, student, this experiment also. Okay, student. So we know lambda is equal to h by p, or what will be p? Momentum of the photon. That will be p will be equal to h by lambda. Okay, and this is, if we multiply here nu, then we may multiply below also nu, lambda and nu. And what is lambda and nu? This is wavelength, and nu is frequency. What is frequency into wavelength, student? That is lambda by t. Frequency nu is equal to, we know, 1 by t. Okay, the reversal of the time period. This is frequency. So lambda by t is nothing but the velocity of light or velocity of photon. So we may write here as nu by c. This is the momentum, linear momentum associated with every photon. So this is also correct, student. So given option C is also correct. And in a photon electron collision, both total energy and total momentum is conserved, student, because the scattering or the collision of photon and electron, we know, is elastic in nature. So student, both the total energy and total momentum is conserved as the collision between them is elastic. So option D is also correct, student. But we know the mass of every photon is zero, and also the charge on every photon is zero, which is chargeless and massless quantity. Okay, student. And of course, the mass is very small, negligible. That's why it is considered zero. But the net charge on it is absolutely zero. There is no charge, neither positive charge nor negative charge. So it is chargeless or neutral particle, photon. So photon possesses positive charge. This is incorrect, students. So ABCD are correct. So this is given in option 2. So option 2 will be correct, student, for this question.